So, as Christine said, my name is Kimberly Green. I am a System Performance Engineer in the Office of Planning at South Carolina Department of Transportation. In this role, one of the major things that I do is help to facilitate performance-based programming and planning and programming. And a key part of this is understanding what kind of transportation and mobility data we have access to, then transforming it and making it accessible for any of our regional planning partners. In South Carolina, we have 21 regional planning partners. We have 10 metropolitan planning organizations and 10 councils of government. I'm going to talk today about a pilot study that we did with two of our councils of government, Central Midlands and Lower Savannah. This study was created in order to promote, prioritize, and coordinate the demand and feasibility of walking, biking, and transit accommodations on our South Carolina roadways. South Carolina owns 41,000 bidirectional miles of roadway. It's the fourth largest state in the United States. And so that makes prioritization really complicated because you have so many miles to consider and so many different area types as well. So the goal here was really just to understand how we can make a data-driven, informed decision as far as prioritizing these different corridors. The first step was to collect data for these two regions. We decided to take an area-based approach, so we first covered our regions with these hexagonal grids, where each hexagon is about 0.1 square kilometers in area. We needed to assemble these key indicators to try to understand the current demand for active transportation trips. These indicators included things like population density as well as households with zero vehicles. Christine mentioned these as well. They're census-based, area-based indicators, and those were transformed to our hexagons via an area weighting system. So the more that a census geography like a block group overlapped with our hexagon, the more priority it got as far as that indicator. The next one we looked at was proximity to these active mode trip attractors. These include things like parks, schools, any kind of recreational facility. And what we did here was identify the straight line distance between the center of our hexagons and those points of interest. The last one, we needed some kind of idea of what the bicycle and pedestrian trips that were occurring actually was. In South Carolina, we did not have any actual counters at the time, and so we procured some segment level bicycle and pedestrian volume estimates through StreetLight. Putting those with our hexagons took a little bit of a different approach. For these, since they are segment level rather than area based, we needed to be really strategic with how we transformed them to ensure that we maintained the correct interpretation of those volumes. So what we did is for every segment whose center fell within a hexagon, we identified the segment with the maximum pedestrian volume and the segment with the maximum bicycle volume. Those two volumes were then added together to create a total active mode volume for the hexagon. So then once we'd assembled all of our data, we calculated a score for those, weighting them based on the priorities of those regions. That then was transformed into an index. We normalized those scores across the different regions, and then that index provided 5 different levels where a darker shade indicated higher demand for active mode trips. So this is one example of how that index could actually inform decision making. This slide provides 2 different maps. The one on the left is exactly those hexagons that I was just describing with the color coding of the index. That dark red is indicative of the highest level of demand. We've also got some linear features on this map that represent the existing bicycle and pedestrian infrastructure in that area. On the right, we have a map of recommended projects. These were assembled using the last 15 years of regional and statewide planning documents. Those were assembled into this one map so we could easily see what were people thinking about as far as adding new infrastructure or improving it. As you can see here, it's really interesting. We have these plans, but we don't have any actual infrastructure being built. And then we understand that these plans could be really important or could be really impactful due to the high demand we're seeing from those hexagon indexes. So one interpretation could be we need to prioritize these plans because there's that high demand with that lack of existing infrastructure. That said, this pilot does not serve to dictate what projects our regional planning partners should prioritize. Again, that goal for us is really just to provide them with a way to think about project prioritization through that data-driven lens. And so thanks to the underlying data that we collected, including the StreetLight bicycle and pedestrian segment level estimates, we will be able to provide our planning partners with that data and allow them to employ that in project prioritization.